What is Cavalieris' principle for cylinders? Imagine stacking layers of different shapes and wondering if they take up the same space. That's where Cavalieris' principle comes into play, especially with cylinders. It's a simple idea but very powerful for understanding volume. Cavalieris' principle says that if two three-dimensional objects have the same height and their cross-sections at every level have the same area, then these objects have the same volume. Think of slicing two objects horizontally at the same height. If each slice in one object matches the area of the slice in the other, then the total volume of both objects is the same. Now, applying this to cylinders, picture a regular right circular cylinder. If you slice it horizontally at any height, the cross-section is always a circle. The area of this circle depends on the radius of the base. If you have another shape, like an oblique cylinder, which is tilted, and you slice it at the same height, the cross-sectional area remains the same as the right cylinders at every level. This idea helps us understand that even if a cylinder is tilted or shaped differently, as long as the cross-sectional areas at each height are the same and the height is the same, their volumes are equal. So, whether the cylinder is standing upright or leaning to one side, Cavalieris' principle confirms they hold the same amount of space inside. For a standard right circular cylinder, calculating the volume is straightforward. Multiply the area of the base circle, which is pi times the radius squared, by the height. But with Cavalieris' principle, you can see that the volume stays the same even if the shape is not perfectly upright, as long as the cross-sections match. This principle is especially useful when dealing with complex shapes like cones or spheres. It allows you to compare a complicated shape to a simpler one with the same cross-sectional areas at each level. For example, you can prove that an oblique cylinder has the same volume as a right cylinder with the same base and height by using this idea. In real-world situations, Cavalieris' principle makes it easier to find the volume of objects that are hard to measure directly. Instead of complicated calculations, you compare cross-sections at every level. This way, you can determine the volume just by knowing the areas of slices and the height. Remember, this principle applies not only to cylinders but also to other shapes like prisms, cones, and pyramids. The key points are that the slices must be parallel to the bases, the areas of these slices must be equal at each level, and the heights of the objects must match. So, in simple terms, Cavalieris' principle for cylinders tells us that if two cylinders have the same height and their cross-sections at every level are equal, then they contain the same amount of space inside. It's a clever way to compare shapes and find volumes without complex formulas, just by looking at their slices.